Alright, we've got these instructions. We check our bill of materials here for making a SOTACAT. We've got our Seed Studio ESP 32C3 microcontroller and a Wi-Fi antenna. We've got our TRRS 3.5 millimeter jack. We've got a red, in this case it's a white LED, and a blue LED. We've got our TRS to TRS. So this one is TRRS, this is TRS. So the way this works is this is a 4-conductor and this is 3 conductors. So when you put the 3-conductor into a 4-conductor, it shorts out 2 of the conductors. That's going to be our power switch when we short that out. That way we don't need a separate switch, we just plug it in. We're going to need an insulator. We've got a 3.6 kilo ohm resistor. We have a 5.1 kilo ohm resistor. We've got a 300 milliamp hour 3.7 volt lithium polymer rechargeable battery. We have 220 kilo ohm resistors. We have some reflective 1 point something cord there. 3 wires, green, red, and black. And we have some big yellow shrink tubing for the outside. And we have a little red shrink tubing that's going to insulate some exposed wires. All right, let's get started. So let's move all this aside. All right, so the first step that we have here is, because things are going to get kind of busy, and this antenna is actually sometimes pretty difficult to get on there and requires a little force. I like to do this right when I get started, even though it's going to get in the way later, because that way we get better access to the antenna port here. So it's very delicate, but it sometimes takes a surprising amount of force to get it right. So you got to get it aligned right, and then you got to get some force. So what I like to do is you kind of feel the lip of it. So I kind of come up from the side, feel the lip, and then kind of roll it on with a very straight downward motion so that I don't bend the pin. But you know, this is the one step where you're most likely to ruin your microcontroller. I wish they designed these a little bit better. Okay, I got it on. Like I said, it's kind of use your fingernail. It is a surprising amount of force required to get that on there. All right. So let's go to our instructions. We got the antenna, so let's do step A, which is getting the red wire and soldering it to the back of the board. So let's get a holder in place. And there we go. We've got, like I said, this is going to get in the way, but we're going to solder to the positive battery terminal that's on the back. You can see right there. We're going to need some extra hands. Now, one of the things is when we solder this wire, it's going to heat it and the insulation is going to shrink. So what you want to do is trim back so that there's just a tiny little bit of wire showing here. And then when the insulation shrinks, it will expose some more. Even that's probably too much there, so let's see if I can get a little bit more of that off. All right. Need enough exposed so that you can get the solder to flow into something to get it started. All right, now we're going to need some helper hands. that lined up. There we go. Looks perfect. All right, give it the old snug test. Make sure that that's mechanically good. Look at it. Oh, yeah, that's not too bad. Not the best. You know, those pads are a little hard to solder on too. All right, that's step A. Let's go to step B. Solder one end of the green wire to the D6 hole on top. All right, let's look at our top. And we're going to do the D6 wire. So that's our serial port wire. That's going to be on this side, right at the bottom. If we put the USB port at the top, it'll be on the bottom left. Let's put it through the hole, curl it around in there. And let's throw that in the holder. And have this hold the wire for us. All right. Okay, green wire's done. At least one side of it. All right, step C. We're going to do the blue LED and the silver lead of the blue LED. Okay, it's going to be the blue. So let's get these wires separated. So these wires, a lot of times, this looks like magnet wire. Maybe it is. Let me get D10. 1, 2, it's the fourth hole down from the top. All right, and there's the silver wire in there. The this insulation, if it's magnet wire, usually magnet wire insulation will burn off with the soldering iron, and you can get a good electrical contact just by soldering onto the insulation. This insulation, my experience is it doesn't reliably burn off, even with a very hot soldering iron, even with a lot of time. So I think you have to mechanically scrape this this off. So what we're going to do is measure the desired position for that LED, which you can, the reason why I put it on the left side is it's very hard to see, but there's the world's tiniest LED, which is the battery charger LED that's built onto the board. So we don't want to cover that up, but we need it to stick out of the package this is going into by the USB port. So I put it right there, and the silver line is going to go into D10, and the orange line is going to go into the, not the ground one, that would be bad. We're going to put that in the third hole down from the top, which is the 3.3 volt regulated feed. The wires will cross, but remember they're insulated. So what we need to do here is we're effectively measuring and routing these wires, and we will now trim these, and then we've got to figure out right where the bend is. We're going to remove some insulation mechanically with some sandpaper and get the end of this wire exposed. So let me trim that. I'm going to curl it up like this, curl it around so I have something to work with. And just double check that that's in the right spot there. Okay. So now I got to take it out. So I'm going to uncurl these. Of course, you don't want to bend these wires too many times because they'll just break. So let's pop that puppy out. And then we're going to take these just the tips, because we don't want the insulation to be rubbed off higher up. We'll get a short circuit. We need that insulation there. So we're going to just get the insulation off the tips here. I have another tool that makes this easier, but you might not have it, so I'm trying to do it the hard way with sandpaper. So we just need to just get a hole, some kind of hole in that insulation that the solder can get into. So I'm going to kind of sand one side and then the other side. And I only want the tip, right? We're just trying to get the tip. And make sure we do that for both of the wires. Another thing you can sometimes do if you're careful is take a really sharp blade, like a box cutter or something, and scrape it without breaking the wire. Okay, so we'll do one side, flip it around, do the other side, and hope that we got somewhere in there a break in the insulation. Like I said, it may look like it's coming off, but my experience is this insulation is pretty tough compared to normal magnet wire insulation. I might get out a blade and scrape it. Here, let's just use some cutters and not actually cut it, just kind of scrape it. Scraping that stuff. All right, I think we got the insulation off. So we'll come back to our microcontroller. And again, we're putting the orange wire in the 3-volt slot, which is the third hole down from the top where the USB is on the right. And then the silver wire goes into D10, which is the 4th hole down from the top. And then we're going to, again, bend this thing into place and curl those wires around and make sure that we didn't take too much of that insulation off. You can see there's a metal can right there, so if that's not insulated, it's going to cause a short. But that looks pretty good. So let's get that soldered now. Now we don't want to do this too tight because we don't want to crush that can, just snug. And let's flip that at an angle where we can get the solder in there. I'm putting a little bit more solder than I normally would. I want it to roll down the side because I can see there's still insulation here. And I'm trying to get as much surface area. Yeah, I could see that wire probably still has insulation because the solder is not flowing onto it. It's there. I think I got some on the side. All right, in this next step, we're going to get our red LED or white LED, depending on which one you have, but the one that's not blue. And we put the silver in hole D8, and we're going to put the orange wire in D9. And again, we're going to align that up. On the side of the board. You can always tell white LED, the center of it looks orangish. That's the phosphor that makes it glow white, I think. And so we're going to measure and then we're going to trim and then we're going to sand off the insulation or scrape off that insulation. So I like to bend it around like this, get that nice and measured properly. And we're going to trim, and we're going to trim, and we'll pull that out. And now we have to sand the ends of that. So I'm first going to start by scraping. Last one we had trouble we didn't get enough of the insulation off. I could tell, you could tell if the solder doesn't stick that there's still insulation on there. Okay, now I could see some shininess. Whoops, I just mangled my wire. Don't want to do that. Going to be gentle. Don't bend it too much because it'll just snap. Let's rotate it and scrape it from this angle, 90 degrees, trying to get more spots where there's no insulation on the tips. Again, you don't want to take more off than just on the tip because we don't want to cut a short, right? We need it to be insulated everywhere except where we're going to solder it. Okay, obviously there's a better way to scrape, sand the end of this. Let's see if I can find a better way. Let's spin that upside down. Do the other side. Okay, now let's put it back in, solder it up. So again, we're going to put the orange. I think of the top as the side with the USB. So we're going to put the orange on top, silver on the bottom. And curl each of those around and up onto the castellated pads. And then route that LED and bend it into the position we want it to be in. Kind of like that. And then once again, time to solder. Let's hope it sticks. I can see those aren't deep in the hole there, so I'm going to push it all the way down in the hole. And I'm putting a big blob here. Again, this isn't the way you should solder, but I'm struggling with this insulation. It doesn't like to come off. In fact, I'm going to put way more solder than I need because I'm looking for any spot where I got that insulation off. So I'm going to do it on both sides. All right. We now have our LEDs in place. That was step C, D, and E. Now we can go to step F, which is to get our 120 k ohm resistors. That would be these puppies here. And they're going to go into both of them go into hole D0, which is also the analog input A0. So here, I gotta get my special glasses off here. Keep having to switch glasses. Whoops, got one through, but not the other. All right, can we get, the LEDs are kind of in the way there. Let's try that again. Can we get both of them in the hole? These resistors have longer leads than the ones that I've been dealing with before. I mean, not longer, but thicker. I might not be able to get both of those through that hole. All right, so in this case, what I found is that sometimes I get resistors with leads where they're thin enough that both can go through the hole together. In this case, these leads on these resistors are a little thicker, and I can't get them both to go through. So here's what I'm going to do. I'm going to put one through almost all the way down. I'm going to kind of bend it out of the way there. You can actually bend it in such a way that you can, we're going to bring the other resistor on the outside near that castellated pad, and then I'm going to wind these two resistors together. Okay, so you can see I'm kind of routing it there, making sure I don't short anything else out. And I'm going to wind those things, get it as tight as I can to that castellated pad there. Now, one of the resistors, remember it's not insulated, and this USB can is at ground, and we actually want this other end of this, one of the resistors, to go to the ground on the opposite side through that hole. So we're going to route one of those through there. And that was the hole that I accidentally got solder in. So now I'm dealing with my earlier mistake, so I'm going to have to melt that while pushing this through the hole. All right, kind of corrected my mistake there, but so we have the two 120 ohm resistors, both going to hole A0 or D0. That's the analog input, the top hole on the left near the USB port. And because my resistors couldn't fit both leads through the hole, I put one through the hole and then wrapped the other around and twisted them together really close to that castellated pad there. Bent the LEDs out of the way. And then one of the two resistors just has its lead not connected yet. And the other one I've run through the ground hole, which I had made a mistake earlier and boogered it because I got a little bit of solder dot in that ground hole when I was working on the LED pins. And so I had to do a little repair work there. So that took some time, and that's why the wire's all bent. But you're not going to do a mistake like that. You're going to get it perfect. And you could see that this resistor wire is exposed. It's not insulated like the LED wires are. But this can here, this USB can and all this is all ground anyway, and we're putting that end of the resistor into ground. So the fact that it's not insulated really doesn't worry me, because we're connecting it to the very same potential. All right, now we do need one more thing to connect to ground. And again, because these LED wires, these resistor wires are so thick, we're going to have to do the same trick on the other side. So where'd my black wire go? Get your black wire, if you can find it. All right, so we're going to get our black wire here. And then I'm going to take the insulation, because we don't want to short out the pin next door. So we're going to wrap that ground black wire around the resistor that's going through the ground hole. We're going to solder that all together, and then we're going to trim it back. We're going to do the same thing with these resistors that are trimmed together. We're going to solder them in there and then trim them. Make that real short. So, all right, let's put that in the holder, and let's solder all this together. All right, so there's our resistors and there's our ground. All right, I'm going to bunch up that wire so that's nice and close. Spin that up so we can get the castellated part. And it looks like I already did. Yeah, those are already well joined. Don't have to do anything more. And we're going to trim this as close as we can. Now, you want to make sure that there aren't any sharp points. Our battery is going to go there, and it's a lithium polymer battery. And the last thing we want is to put something sharp that punctures into the battery. We're going to put a mat in between these things. But when you trim, if you can trim in such a way, or aim the wires when you're soldering such that they don't point down but point to the side, you're going to improve your you're going to make it so that you're not puncturing that battery with something sharp. Like I said, we'll put a pad in between just to make sure as a kind of a backup, but nobody likes to play with lithium polymer fires. All right. Now, why did we have these two 120 ohm resistors going into that one hole? What we're going to do is one side's going underground, the other side is going to the battery input, this red wire here, which is coming from the battery. We're going to bring that around, and we're going to twist these together, and that creates a voltage divider. These resistors are the more accurate 1% precision accuracy on these 120 ohms, K ohms. And so that's a voltage divider that's going to take the battery's input voltage and cut it in half. And we're going to the analog input on the microcontroller, which is going to measure that voltage, and that's going to allow us to read what our battery voltage is. Now, lithium polymer batteries, they pretty much hold their voltage for most of the discharge cycle before they drop off. But they do decrease a little bit. So you can tell when the battery's really full, and you can tell when the battery is nearly empty, and you have less accuracy in between. But we could still measure it and still use that information to alert you when you've got a low battery or if the battery's fully charged. All right, and we could do that in software, which is the whole point of putting those resistors in. You also have that tiny, tiny little charge light, but it's very hard to see that thing compared to these LEDs that we've added, which are quite a bit brighter. Okay, what's next? That was step F. And G, and now we are doing step H, which is getting both of our 3.6K resistor and our 5.1K resistor. This is our voltage divider that we're building for the serial port. The voltage coming out of the Elecraft radio is too high for this microcontroller, so we're using a voltage divider to bring it down. And that took a little bit of calculation and computation. I had to look at the circuit that's actually inside the Elecraft, because they've got a capacitor and some other protection elements in the Elecraft, which changes, it basically creates a time constant. So when you're going at fast baud rate, we want to use as big resistors as we can for the lowest power, but we need small enough resistors so that that capacitor doesn't kind of load the circuit too much. Anyway, these are the ones that I found that are going to work well for the Elecraft. All right, so both of one end of both of them is they're both going to go into that hole D7, and I think we're going to, because again, unless these leads are, I think these leads might be a little bit smaller. Let's see if we can get them both into the hole. Because that, look at that, both go into the hole. So these resistors are nicer in that respect. We could solder them both in there. And we have to figure out which one of these two resistors is the 5.1K, and that is, let's see, the one that's got the orange band on the end is going to be the 3.6K, and the one that has the green band on the end, that's going to be the 5.1K. So we want we want to kind of bend this in place that the 5.1K is going to go in that nearer hole, and the 3.6 is going to go into the farther hole. In fact, I might not solder that quite yet until we get that board in place. Let's bring that into play. So again, the orange is going to go into ring 2, and the one with the orange band is going to go into ring 2. But we also have to get a wire into tip, which is this green wire. So we have to measure how much green wire we need. So let's route that green wire. And the two boards are going to go together just like that. I'm going to move our coax out of the way. Okay, so we want our green wire to go there, so we're going to trim it probably just something like that there. Let's cut that. And then we'll strip that green wire off there. I hope I didn't strip off too much. Hopefully I have a little extra of the green wire. And we're supposed to, in the instructions, we're supposed to solder these two resistors, but the order doesn't really matter. It's just the order has to do with making it easier to get all the stuff in the right place by the end. So, all right, if we put that in the tip, and if I line that up like that, actually, I think I want to go over top of the antenna. I want that wire to kind of hold that antenna in place. The antenna coax. See if we can get it to route that way. This is all kind of fidgety. Okay, bend that around. That looks good. So now we can route the one with the green, the resistor that has the green band on the end, and we're going to put that into ring 1. And then the resistor that has the orange band on the end, we're going to put that into ring 2. And ring 2 also is going to have the other end of that black wire. So we don't want to solder that. That's a common mistake. If you look at the instructions, you'll see all the letters in the instructions either have a green circle around the letters. If you look at the letters in the instructions, see how some of them have green around the letters and some have a red circle? The red circle means that that hole is going to have 2 wires going through. So don't just put one through and solder, because now you've just ruined your project. So the red is to remind you that, hey, that hole is going to have 2. So this hole here, ring 2, that's a red one. That means there's a second wire that has to go in there as well. And that's the other end of this black wire that we just did, the ground wire. We got to route that down and see if we can get that to go through the hole. So I'm going to route that, measure, give myself a little extra, and then trim that. And then now I'm going to, let's bend these resistors into place so it kind of holds everything together. So that holds all that together. And we're going to take this black wire here and trim that, or strip that. Trim. Already trimmed it. We're stripping now, not trimming. All right. And so this black ground has to go through that ring 2 along with the resistor that has the orange band on it on the end. And look at that. I just boogered that wire. Let's try it again. Spin it, spin it, spin it. Twist all those together, those strands. And I should probably put on my magnifying glass because I can't really see what the heck I'm doing. But then if I do that, I can't help you guys. So I'm going to put on my magnifying glass and put that black wire through that hole with the resistor. Okay, let me take my magnifying glass off. All right, now you got to make sure you don't have any shorts or anything here. Of course, these two things should be shorted on the one end here, where the 2 resistors are going through the same hole. But these do not go through the same hole on the other end. And let's, so we got a black wire and the resistor with the orange band, which is the 3.6K. Going through ring 2, and we have the one with the green band, which is the 5.1K, going through ring 1. And we're going to solder all this stuff together. And then, of course, how are we going to get this to be held in place? We might need the extra pair of hands. Got so many wires here now, there's less place to grip it by. All right, make sure you look under the magnifying glass that you're not shorting anything out here. Everything's so small. Old eyes can't see as well. I almost made the same mistake I made with the ground line where I touched the wrong one. All right, let's get the green wire. And again, I pushed them all to the side so that the pointy bit, when we trim it, doesn't point down into the battery, but instead points to the side. So magnifying glass off. It's really hard to do a video at the same time you work. It's much easier to just work. All right, trim that. Trim those. Trim that. And I can see I've got a whisker in there. I'll look at that whisker under magnifying glass, make sure it's not shorting anything. It is shorting something. All right, so I bent this green wire all the way around and it's touching the resistor, and I don't need it all the way twisted around. So I'm going to trim that back so it's not even close, so it can't ever get there. All right, that looks pretty good. pretty good. All right, we got our black wire, we got our antenna wire, we got everything's coming together. All right, what's the next step? So what step did we just do? That was step H and I and J and K. Now we're on step L. So for step L, we're going to get the battery. Which battery? Those aren't the right battery. Here's the right battery. So we have our battery, and it's got a JST connector on the end that we aren't going to use. So we're going to cut that off. Always pains me to cut off. I hate having to hand make JST connectors. I can never get it to work. So when I have a pre-made JST connector, I love it. And so cutting one off just pains me not to use one because I've had so much trouble with those stupid things. Never could figure those things out. So we're going to have to combine. What are we going to do on the red? We're going to take the battery's red wire. We're going to take our red wire that goes to our board, which is our source, and then we have this one resistor here, which isn't connected on one end to anything. Our 120k ohm resistor that's down here was never connected, and all of those things need to come together. So I'm going to find some way to route this red wire so that it comes around kind of like at this angle, so that it's going to terminate on this resistor, and then we're going to bring the battery in there. And we're going to figure out how we want this battery to be oriented. I think I'm going to do it like this. And then so the red is on the right side, and then just curl that up into this connection that we're going to have. All right, so let's do that. Let's, what we're really doing here is step M. And then we're going to go back and do step L. Might be a little easier just the way things are laying out. Doesn't really matter what order you do it in. Or does it? Let's see, because this black wire in step L is going to have to come over here onto this board. There's a couple ways we could route that. Yeah, I'm going to do the red ones first because it's so busy. So before I make everything more rigid, I think I definitely want to get this coming in here. So I'm going to measure, I'm going to route the wire, the battery wire from our board up through here and give myself some amount of space to strip that. So we're going to trim it, strip it, and then wind it around. We could strip quite a bit off. I gave myself quite a bit of extra, and I'll be able to trim it again when we're all done. So you can see I've trimmed quite a bit off, a little excess. So we're going to bend that around, get to this resistor here. I'm going to bend this resistor off to the side just to prep everything, and then get those things wound, and we got to get our battery in there. So let's go take our battery red terminal and strip that. This one I don't think we had as much spare to work with. Okay, that's a real wire there. That's not that silicon stuff. So I'm going to use wire cutters for this instead of that other fancy tool that I have. Okay. Three things going together. Why don't we take our battery and our other red wire, take the two red wires, and let's twist them together first. That'll give us maybe mechanically something more to work with here. Okay, and then we're going to take those and bring them up and twist them onto the open end of this resistor here. And I probably should have stripped off even more of these wires. I wish I had just a little bit more to work with here. All right, we're going to solder those three things together. Resistor, red wire, three things. Put on my magnifying glasses, which have disappeared. All right, and let's solder those three things together. Okay, now we can trim that back. And then we have our insulation tube, because this will short stuff out here. So if we get this in a nice straight line, we take our red shrink wrap tubing and we just put the whole thing over that whole assembly there of those three things, just covering up the resistor and the exposed wire. I'm going to measure that and trim this a little bit more. So let's say to about there. Put that on there. You could use a flame, or in my case I'm going to use a heat gun and shrink that tubing. Okay, let's squeeze the end. I think this, sometimes this tubing has glue in it. And if you squeeze the end, you glue it shut so nothing can get in there. All right, nicely insulated. And we've got one more wire to do, which is we got to strip the black wire coming from the battery now. And again, these are real wires, not that nice silicone stuff, so got to use the real wire cutters on this. And that ground wire is effectively becomes the power switch. So again, the yellow side, we're going to route this red on the one side here, and we're going to route this black around up and through that hole, which is the sleeve hole. Again, I might have been off camera there, so let me do that again. So I got the USB port here, and I took the battery's red wire and come around the side, and it goes into what we just soldered. I'm going to take the black wire, route that around, and it's going to come up, if we twist that, and put it into the sleeve hole. And the way this works is there's no power switch, but when you plug it in, it shorts this ground from the battery, which you can see is not attached to anything else. We're just putting it in that sleeve hole. But when you put a TRS connector into a TRRS jack, by the way, the T stands for tip, R stands for ring. That's a tip ring sleeve. So there we go, tip ring there. So we're going to put that into the sleeve. And let's solder that into place. And that's going to go just like that. And those things got really close there, so we got to be careful not to short those two things. Let's bring this back into place. How am I going to grip this thing? Let's try it this way. We're almost done with the hardware part, and we're going to do the software part. You know, I'm just going to use the helping hands. All right, magnifying glass for old people like myself. Not that old. Not that old. Who am I talking to? All right, as I was saying, that ground is not really connected to anything. It's connected to the sleeve until you plug it in. When you plug this in, this is not a TRRS. This is a TRS, tip ring sleeve, and we're putting it in a tip ring sleeve jack, and that will short both the sleeve to the ring 2, and that's what turns the power on, because it allows the ground from the battery to connect to the ground for the rest of the system, and that turns it on. All right, so let me just double check my work in the magnifying glass. Looks good. Okay, that was step L, and we did step M, and now we need to do steps N and O, which is to get our cord. So I got my hot glue gun all warming up, and what we're going to do is this is the leash for the plug that goes into this thing, and we're going to glue that onto this side, the side with the 2 resistors, and the kind of like that going out from the USB side, because this side's going to plug into the radio, and so we don't want stuff going that way. We want this to hang out this way, and then this leash will come around to the plug. All right. But before we do that, we're going to put in this battery. We don't want any of these Sharpies puncturing that battery. So we're going to put a little layer of padding. All right, so we're going to take this. Is just a Rubbermaid. I just use this Rubbermaid drawer shelf padding stuff. You can get this everywhere. And that hopefully will protect the battery a little bit. And then I like to make this a little more rigid, rather than just depending on the outside case making it all rigid, because we're going to be plugging things into that jack and unplugging them. So I think a little bit of hot glue. Now we don't want to heat the battery up too much, so we're just going to put a little dab and use that to hold this all together. So let's get our hot glue gun ready. And what we're going to do, let's bend the battery out of the way temporarily so that we can get the hot glue in there, put the pad on, and then smush it all together. Actually, I'm going to put the pad in first, because once you get hot glue in there, it's really kind of hard to work anything. So we're going to line it all up, get the wires routed right, and my hot glue gun is not on the super high setting, it's on a low setting. Again, I don't want to cook this lithium battery, but I do want to get some stickiness in there. So I'm going to just put a little, ow, just burned my thumb, line that all up, smush it together. Why is it you always end up putting hot glue right onto your finger? Like I was saying, it's not on the hot setting, so that's good. But even the low setting is hot enough to hurt. All right, got a nice little package there. Got our LEDs sticking out. Let's bend those over so they kind of face out and up. And then we're going to take our Wi-Fi antenna, bend the coax around, and then fold it around like so. Fold it around our package. And then we take our yellow heat shrink tubing, and that is our container. So we're going to pop that open, which is hard to do. I don't have both hands free. And kind of slide that Wi-Fi antenna so that we want it to go down in there. Might need to get a tool. Let's get small screwdriver so I can kind of push that Wi-Fi antenna in as the whole thing goes in. Okay, so this end is lined up, and we want it lined up just to those LEDs in that USB port. And this end is obviously too long, and you know, we can do a lot of the trimming after we've shrunk it down. Now shrink wrap generally shrinks in one dimension and not the other dimension, so it shouldn't shrink much lengthwise, but it should around the circle. So let's shrink that down, and then we get the moment of truth where we get to see if this thing is actually going to work. All right, we don't want to overdo it because again, we got a lithium battery in there, and they don't like to get too hot. So I'm blowing on it to cool it down. I'm going to trim the excess because we need to be able to get to that hole. Now we can leave it, the rest of it closed up nicely. We just need the top part to that TRRS jack to be exposed. So I'm going to trim right up to the jack and then allow it to protect the rest of it. And you want to trim right up to it because we don't want the heat shrink tubing to prevent the plug from seating all the way in. It needs to go all the way in because we need it to short out the ground to turn the thing on. So if you've got some little heat shrink in the way and it doesn't seat properly, you get no power. And that wasn't a very nice job there. I just boogered that, but nobody's looking. Hey, this is only the 5th one of these I've ever made. All right, moment of truth. Oh gosh, you know, I forgot to put the leash in. All right, if you do something stupid like me, we were supposed to heat shrink the leash in there. So what we're going to have to do is kind of feed. I'm going to put a knot. The funny thing is, this isn't the first time I've made this mistake. So what I've done in the past is I've made a knot and put some hot glue in there and just shoved this down into that whole setup, and the hot glue holds on to the knot pretty good. So I'll just put a knot there. Now what we absolutely don't want to do is get any hot glue in that hole, and there's no room to put the leash in on the USB side. It's pretty packed, so the only place I see a nice gap is on this side. So I am going to put my leash in there and get a screwdriver and stuff that back in there ways. And then we need something to fill that hole with. You know, I'm going to get a TRS cable. Alright, so I'm going to plug that in there. And now I've got that hole covered. Now I can hopefully squirt some hot glue down in there and fix my mistake. You aren't going to have to do this because you will have hot glued the leash in there in the first place, and this won't be an afterthought. I can also put a little extra glue to kind of maybe make this a little more water resistant. Seal it up. And I want to make sure that hot glue gets on both sides of that leash down in there. So let's take a screwdriver and push some of that down around. And squeeze it around that thing. Good sign. I saw one of the LEDs barely blink, and that's because we've shorted it. So in effect it's on now. We haven't added any software, so there's no software to tell those lights to blink, but you can see when I twist this, there's a momentary disconnection or bad connection, and so it's rebooting, and you see just a momentary flash of the LED. So power's getting in there, getting to the LED. Only one of the LEDs is flashing. That has me a little concerned that maybe I didn't get enough insulation off the other LED. And then the final step before the software is to get the other end of the leash attached to our male-to-male plug. Unfortunately, I'm making all sorts of mistakes. See, you're going to do this perfectly. I know you are, because you're going to be careful. And you're not going to get hot glue all over the thing that can't get any hot glue on it, because it's important to making the thing operate. All right, got that cleaned off. So now we want to, you know, epoxy would probably work a lot better than hot glue. I'm almost positive epoxy would be a much better solution if you had a good epoxy to epoxy that leash onto there. But since when did a better solution ever stop me from using a worse solution, right? So we've got hot glue ready to go, and we're going to use it if we can get any to come out of the hole. I'm going to push that down in there and get it started. Wrap that around. Oh, shucks. Okay. Now let's get a little bit more hot glue. Okay, now we get to the programming, and remember to turn off your soldering iron. Remember to unplug your hot glue gun, and why not even unplug your hot air gun. There we go. There is a SOTACAT. SOTACAT number 5, I think this one is. They keep getting smaller. This is about half the size of the previous one I made. Smaller battery, smaller controller. Pretty good. And this one has the battery monitoring capability and an extra LED that the other ones haven't had so far. So they keep getting better. Smaller with more features. Hot glue starting to warm up. Put that in there. And you put that in your radio. All right, next step, software.